Hello everyone, I'm Andrew and today we are going to talk a little about Nix language. The format will be pretty simple. I will be explaining some parts of the language and you can ask question whenever you want. And at the end of the day, we won't be able to understand pretty much any relatively simple Nix expression and almost any configuration file you have with a lot of details and different constructions. And first of all, let's start from the simplest thing in the language. It's comments. Comments are good because you can make the code not executed, and it's almost the same as a code which never written, and never written code is the best code ever. It's two types of comments, hashes and multi-line comments. Yep, and that's all about comments. I hope you can hear me well. Let me know if there's some problem. And let's go to the next thing that is probably most important thing in the language is basic types. We will cover only a few types, and it's boolean, numbers, strings, attribute sets, vectors or lists, and passes. I will be copying this text to the Nix file and will be evaluating to show you how this snippet of code works. And let's start from the snippet. Oops. We copied it to the file called example nix, and now I want to evaluate it, and let me toggle kcast to make you able to see what am I doing here. And let's open just a basic shell, and inside the shell I will be evaluating example nix file, and to make it a little more readable I will be using nix-fmt tool, which pretty prints the code or the value that returned by the file, by the expression written in the file. Okay, and now you can see that it just returns a list of those values and nothing fancy. I hope every one of you have at least a basic knowledge of some programming, and everything here is similar to other languages. List is just collection that can be accessed at any index, and it's ordered collection. Basic types, just basic types with basic operations. For example, you can add numbers, or you can use boolean values in if statement, and attribute set or hash map or dictionary is associative collection which has keys and values, and values can be of any type. And pass is something like constant string, but it actually evaluated inside some context. For example, here you can see that I specified ./file, but right here you can see that it evaluated to the full pass. And the context for this pass was the file example.nix, which based in this directory. That is why this ./file evaluated to the full pass like that. And I will put few links at the end of this document, and also I will put them in the description of the stream. and we will be able to learn more about it. Okay, I think it's enough about basic types. Let's talk a little bit about attribute set. Attribute set or hash map or dictionary is very important part of the language. For example, using this type can be implemented some cool things like namespaces for Nix. Nix doesn't have namespaces, but using those attribute sets you can get something similar to namespaces. And let's one more time copy our code to the file, and let's evaluate. Let's start from the simpler example. Here you can see that there's some special word called rec, and I will explain what it does in a few seconds. But let's start from simple example. Simple expression. The important thing that I didn't mention, Nix file contains one root expression always. You can't, for example, place two expression in one Nix file. For example, this code will be invalid. Let me evaluate it. I restarted OBS and I hope you can see and hear me. Oh, it seems it works. Let's go back to our attribute sets. As I said, every file with Nix expression contains only one root expression, and all others should be nested somehow. And let's go back to attribute sets. The simple example is here, but more complicated example is recursive attribute sets. It's type of attribute sets which can reference the keys which are declared inside it. For example, it's a valid declaration of attribute set if it is recursive. And let's evaluate one more time, and as you can see it works, and it's actually can be some function. And one more time, still works. But if we remove this rec keyword, it will throw the error. Also, attribute sets are lazy. For example, I can reference the key inside nested value, and I will be able to navigate as deep as I want. Let's check it, and as you can see, it always returns another attribute set which contains another attribute set and so on, and it also detects that it's cycle and doesn't evaluate it deeper. Cool. And another interesting feature that instead of a key, you can provide a path like few keys separated by dot, and also key can be everything, and it also can be a string. Actually, not everything. It can be just a string or a key. And for example, here you can reference another value inside this hash map, key2, because it's a recursive attribute set. And as you can see, it created a nested attribute set which contains attribute set and which contains attribute set. And it's almost all about attribute sets. I hope nothing tricky. yet. And if you have any questions or need additional explanation, let me know. Let's go to strings. Strings is almost basic strings as in every other language, but the only difference is that you can include some code inside those strings using this notation: $, curly braces, and code inside it. For example, this code should evaluate in multi-line 25 string with multiple lines. And let's copy this code to this file, and let's evaluate this code. And you can see that it returned a string, multi-line string. And to make evaluation process a little more simple, let's create a macro. This macro will be copying the code to example.nix file and switching to this window, calling previous command and returning back to original window. Yep. And it works. Multi-line strings is almost the same as basic strings with double quotes, but it uses 2 single quotes. Yep, that's all about strings. And obvious question: what you can do with those strings, attribute sets, and lists, what operators available, and so on. We will tell about it later. You can expect basic math operators like plus, minus, and so on. I didn't forget about passes. I talked about them here. Maybe if you have any additional comments about passes, I say that they are context aware and should be evaluated to full pass during evaluation. And if you have additional interesting comments about them, we can talk a little more about it. Okay, there are not so much different conditional statements in Nix language, and most important one, and maybe only one, is if statement. And actually it's not a statement but expression, and it always must have 2 branches, then and else branch, because it always must return a value. And it's the same as in another languages. You have some condition, first item to return or second item to return in case condition not satisfied. And let's go to the functions, because Nix is a functional language. It's important part of the language. Let's evaluate this block of code, and as you can see, it returns a lambda, which is anonymous function. And the syntax is pretty simple. You have argument, colon, and the body of the function. For example, here we have a function which accepts 1 argument and returns an attribute set with 2 keys t and b is equal to input argument. And actually we can evaluate this function by passing it an argument. For example, something. Oops. And let's. It says that it returns lambda. 1 second. Okay, it works. Application of the function. You have a function somehow declared. It may be anonymous function or named function, and you can call it with arguments, just placing those arguments near this function. but you can use par parentheses like in a Lisp to make it clear that this argument will be passed to this function. Yep, and application is almost the same that we did right now. And more complex cases, you can define function with default parameters, you can define function with multiple parameters, and so on. How we define function with multiple parameters? Let's simplify our function to something like a plus world. Yep, seems valid. Let's evaluate it. Something world. Cool. The basic function accepts a string and returns string plus another string. And now we want add, for example, another parameter which will add a prefix to the strings. What we will do, we will type another function which accepts prefix and returns this body, but it also uses variable a, which should be somehow populated in our scope, and this variable will be populated with another function, and it's actually a function which returns a function which concatenates two strings, and let's concatenate 3 strings. If some of you familiar with functional programming, it's called carrying, and you can treat it as a function with 2 parameters, but it's actually a function which returns a function with 1 parameter, but it works almost the same. And let's evaluate it. And as you can see here, I passed only 1 parameter to the function. That is why it returned a function which accepts 1 more parameter. And that is why I can pass another parameter to this function. Something prefix here. And let's evaluate it. And you can see now it's evaluated correctly. But also you probably can use it as a function with just 2 arguments, like that. You have a function with 2 arguments and you pass those 2 arguments here. And it also works. Cool. And let's go to some more interesting cases. For example, I want to pass few parameters to the function, but I want to make them some of them have default values. For that, I can use a different notation. I can actually accept attribute set, only 1 argument, which is attribute set, which contains few keys, for example, a and prefix, like that. And here, instead of passing 2 arguments, I will be passing only 1 attribute set. Let's move it to next line for readability. And this attribute set will contain key A and key B, like that. And it should work. Boom. Unexpected space. I forgot something. Yo, I need the help. Some help. Oh, it's not B. It's prefix. Yep. Now it works. I just misspelled. and instead of setting prefix key, I used B key, and it works. But if for some reason this attribute set contains another parameter, which for example will be C, it will throw the error because this function accepts attribute set with exact two keys. And to make it accept attribute set with more keys, I need to specify it using this strange notation with multiple dots. And now it works with additional C key. And also we can do another interesting thing. We can say that this all those key should be accessible. The whole attribute set can be accessible by variable called args. And now let's return args.a instead of a, and the value will be the similar. And instead of returning string, we can return attribute set to make it clear that args will contain the whole attribute set. Yep. And you can see here it returns attribute set with res key, which contains all arguments. Pretty cool so far. We learned everything that probably can be confusing about functions in Nix programming language. And let's go to the scope helpers. Scope helpers. Let's take this example. Let's start from first helper called let. It allows to declare some variables which will be available in our scope. For example, I can define a variable str which contains string, and I can say that my expression returns as str. And let's evaluate it. And it actually returns string. Now we can concatenate the string with something, and it also will work, as you can see. And now we can access not only string as str but also a, and instead of returning the whole a, let's return a b. And this example shows that instead of returning the whole a, you can return the value only of one key. Pretty cool so far. What else we can do with let? Actually, with let we can define functions. Because function is first order citizen in Nix language, we can say that our function will accept argument and return this argument plus world. And now I can return this function as a result of this Nix expression, and you can see the result will be lambda. Lambda is anonymous function, and we also can call this function with string argument. Boom, and it will append world to string. That's how we can define named functions, one of the ways. Also, we can place this function inside attribute set. For example, we have attributes set called functions, and inside this attributes set we have a function called worldificator. which will be equal to f1. And instead of calling f1, we can call functions.worldDificator and with one argument str, and it still works. And instead of str, we can say hello, and it also works. Cool. We almost implemented namespaces in the language which doesn't have namespaces, because it has a pretty nice syntax to access attribute set values, and it looks almost like namespaces. For example, we have worldDificator function under functions namespace, and this function namespace defined just as a variable, as attribute set. And now we want to have our worldDificator function available without using this namespace. And to make it possible, we need to use this statement, which accepts an attribute set, for example, functions. And when we make this statement, it says that everything inside this attribute set available as a variable to the scope in our scope. And after that, I can use worldDificator without functions dot prefix. And let's evaluate our code, and it also works. Cool. And another interesting thing that helps to operate with big scopes is a inherit keyword. And what does it say? For example, when we define attribute set, for example, we define res key equal to result of worldDificator function. But we also want to add a few more keys from our scope to this attribute set. We can say inherit, for example, str and f1. And after evaluation, we will see an error because the syntax isn't very perfect in Nix. And in inherit you don't use comma. Oh, actually it's the same as in lists. You just provide a few in the identifiers, and it creates keys equal to its values. For example, it creates key str with value string, and it creates key f1 with value lambda. And you can see here f1 and str keys is available in our attribute set. Cool. I think that's all about scope helpers, and let's go to another interesting, or maybe not very interesting, thing that allows to split our Nix expression among a few different files. And it's an import keyword which allows to get the result of Nix expression inside the file. For example, we can export some Nix file, and here in place of this import file we will get the value of the expression inside sum.nix file. Let's see how it works. Let's create sum.nix file, and let's place just a string as the root value of this file, and here this statement should be evaluated to the string. Let's check it. Yep, and we evaluated example.nix file, which contains import statement, which just evaluate expression inside some.nix file and returns it. Okay, let's do something more interesting. Let's define a function inside some.nix file. It will be a function which accepts one argument and returns hello plus this argument. And now, if we evaluate the same thing here, we will get a lambda as a result. Oops. It's kind of expected because the root value of the some.nix file is a function. And we also can pass parameter to this function by just mentioning this parameter here. And it will evaluate this expression, we'll get a function from it, and we'll apply this function to this argument. And now you probably understand what does this thing means. It says that it wants to import a nix packages file. It's special notation which during evaluation will be converted to current nix packages, and it passes empty list of empty attribute set as an argument to the function, which will be a root expression inside nix packages. Yep, and it's almost all about module system in Nix language. You can split your expression in files and use these files using import. Actually, it's almost the same as eval in other languages. And now let's talk about functions that you can use for operate on strings, lists, and attribute sets. For that, I will take this example, and this example shows how to import a lib attribute from nix from a function, from the result of the function after importing nix packages. We get a function. We call this function with empty attribute sets, and it returns attribute set, and we take in a lib key of this attribute set. And for example, we can look what is under inside this lib, but let's take a look at a little deeper in strings attribute of lib attribute set, because lib is pretty big attribute set and will take a lot of space on my screen, or even strings will take a lot of space on my screen. But you can see that lib.strings contains a lot of functions with different names, and you probably can guess what those functions do. But to be sure what they do, you can go to GitHub and take a look at implementation of those functions inside string.nix file, and you can see that implementation of all those functions is pretty simple. And you also can read some explanation on how this function works and what they produces. Probably there are some other way to get information about those functions on some site or maybe somewhere else, but most reliable and interesting way to do it to just look at source code. And funny that it's not a built-in library, it's a separate library implemented in Nix packages, which is a collection of packages defined in Nix language, and it not shipped with language itself. Only thing that shipped with language itself is attribute set called Builtins, and it's implicitly available in all scopes inside this language. And actually we can just take a look what it contains. Builtins, and you can see that it contains a lot of things, and they called premob. I suspect that it's some kind of functions which implemented using C or C++ language, and here is a reference to such functions. That means that they should be pretty efficient. And you can see functions like lm or lm_add. It's functions for manipulating with lists. For example, you can take built-ins lm_add, probably list is the first argument and the value is the second argument. I'm not sure, but let's check it. Actually, we don't need to export anything. It's already available in the scope, even without any imports. Where is my... Here, you can see it returned the second element of the list, and it's 3, which is correct. And you can find all other functions inside this built-ins attribute set, but also much more function is available in lib attribute set inside Nix packages. That's how you get almost all useful functions for operating on basic data structures in Nix language. And let's go to loops section. And there is no loops in Nix language, and you can't use familiar for you for E in range or something like that. But you can use high-level functions, high-order functions, map, filter, and fold L, which is, or fold R, which is the same as reduce function is in any other functional languages. And using those functions, you can implement always all the things that you expect to from loops. For example, you can take a list of values and function will be, for example, r more than 3, and let's take a list which contains few numbers. I don't remember exact order of arguments for filter function. It's built-ins filter. Okay, it's correct. High order function accepts other functions as arguments, and the filter, for example, iterates among all elements inside the list and checks the value of this predicate predicate is a function which returns true or false, and if the value is true, the element will be in the resulting collection, and if the predicate returns false, this element will be removed from this collection. And as you can see here, the resulting collection contains values only bigger than 3. And actually, if I place a few more elements here at the beginning of the list, you can see that they will be present at the resulting collection. And all other stuff that you basically almost every time implements using loops in your language, you can implement using those high order functions. Probably there are a lot of explanations how to do it in different languages, and Nix doesn't differ from those languages. In the definition of Nix language, it's said that it's a pure functional language, but it's actually not true. It's not pure, because it can do side effects, and let's talk about two types of side effects. One of them is accessing some data, and another is writing some data to somewhere. And for example, the simplest example here is accessing environment variables, which is not pure, because depending on the environment where we evaluate this code, those values will be different, which make this expression not pure. And also there are accessing to Nix packages. It also depends on the environment in which this expression evaluated. And in the next video I will be talking about flakes, and will explain how to make evaluation of Nix expression almost pure. It will force all the code be pure on reads. It means that it won't be able to access Nix packages in such a way. It won't be accessed. It won't be able to access environment variables and so on. But it still be able to write some files, but it will be able to write them only in store. And nice property about this side effect of Nix language, that writing to Nix store is idempotent operation. That means it doesn't matter how many times you run it, it will write the same result. And if you modify the content of the file or the recipe of package, it will produce a different result. And let's go to the example. And here you can see that I create new package called hello.txt, which contains hello world. And let's evaluate this file, and you can see that it accessed my hello Pablo. Sorry for making your eyes bleeding, but for a lot of time I use light them, and it's pretty nice in terms of pleasure for my eyes, and I find it more appealing when you have a long working session. But maybe I will have a separate stream with dark them someday, but not today, sorry. And as you can see here, it created a file inside Nix store and prefixed it with hash. And if we evaluate this file one more time, it will create absolutely the same file. But if we modify this file, for example, hello my world, and we'll try to evaluate it, it will create a file placed in a different place. That means that this operation is a side effect by its idempotent side effect, and you won't be able to mess the Nix store writing to it some stuff, because all the stuff guaranteed to be idempotent. All operations writing the stuff guaranteed to be idempotent. Yep, that's all about impurities, I think. And let's go to very hard topic, which I won't be covering in details right now. It's models. It's a system which allows to define a complex configurations using this Nix language. And the model contains of its attribute set of function, which returns an attribute set. For example, it can be something like function accepts config and packages and something else, and returns attribute set. And this attribute set should contain options key and config key. Options key defines which attributes you can set in your configuration, and config is actually a hint which values should be set to the attributes of other models. And to understand on the example, let's take a look at Emacs model of Home Manager. And here you can see that it defines options key, and inside it defines some options. For example, programs.emacs.enable is option of type enable and with description equal to Emacs. And here you can see option programs.emacs.package, which defined more explicitly with type equal to package with default value equal to Emacs, and default text, example, description, which will be used inside documentation generated from this code. And here you can see the config key, which contains definition of attributes of different model. For example, it defines attribute home.packages, which equal to cfg.finalPackage, which is a reference. CFG is a reference to config programs Emacs, and final package will be taken from here, and it can be defined by this line, and also the value of final package can depend on another value defined by user somewhere in his configuration. For example, a user can define extra packages, and it will affect the final package for Emacs. It's complex because there are a lot of implicities. For example, those parameters config, lib, packages passed through special meta argument somewhere, and also all that stuff is merged with some pretty complex algorithm which respects some metadata which can be set on different keys of these attributes sets. And it's a really big topic, and I would like you to explore it in more details by yourself, at least for now. But very basic idea, I hope, is clear. Models define a list of options and defines the values of options of different models that it wants to use, and the user defines options available for him in his configuration. And that's how those models works. What my thoughts about flakes? It's a good question, Pablo. I think they're ready to try. I already use them for a few months and it works pretty good. And many people in at least Russian community use them. And also my next video, which will be published in 2 weeks, will be about basics of flakes. And you can take a look at the example of different configurations of people from community which uses flakes. The most beneficial thing about flakes that you don't have those impurities. You don't depend on Nix package version. This Nix packages version specified in flake.log file, and it's frozen, and you can manage when you update it. And also, for example, if you reinstall the system or building a system for a different PC, you doesn't depend on Nix channels or something like that. You're pretty sure that your system will be built from exact version of Nix packages. Actually, it's pretty easy to jump from your current configuration, I suppose, because everything you will need to change, you will use import inputs.nix packages instead of nix packages, instead of this. And that's pretty much it that you will need to do. Also, you will need to specify system here, because when you import something, there is explicit argument for the system, which is equal to current system, but because it's a pure evaluation in Flake, you do a pure evaluation, it will be necessary to specify system by yourself. But other than that, it should be pretty easy to switch from any configuration to flakes. Yep, I agree, it improves reproducibility a lot. And let's go to the last part of our talk. It's list of links. I encourage you to visit Nix packages sources to understand how some functions implemented in it. Also, if you are not familiar or want to have some practice with Nix language, you can use Nix Cloud Tour, which have a lot of exercises on basic Nix constructions. And also there are resource learn X in Y minutes about Nix. It has section about Nix, and it also contains some basic information about Nix syntax and few more links with brief overview of Nix language, which also can be helpful. And I hope now such type of Nix expression doesn't scare you, and you already understand what is going on here. And I'm glad that you enjoyed the stream, or at least joined the stream. See you in the next video in 2 weeks. Bye.